are told a car is traveling at night along a highway shaped like a parabola with its vertex at the origin. So we can see on this diagram here that we've got this black parabola, and we know that the vertex or the lowest point is at 0, 0, the origin. So we are told that our car starts at a point 100 meters west and 100 meters north of the origin. So if we remember our compass directions, north, east, south, and west, never eat soggy weeds, we know that if you start at 0, 0, and you go 100 meters west, which is to the left on our diagram, we know that you'll end up at negative 100 on the x-axis. And if you go 100 meters north from 0, 0, which is the origin, it says 100 meters north of the origin, you'll end up at positive 100 on the y-axis. So if you look at that on a 2D xy plane, our car starts at negative 100, 100. So that is a point on our parabola, and our car starts there. We are also told that it travels in an easterly direction. So what that means is that it goes down this parabola and then up. It's traveling to the east, which is to our right on this diagram the entire time. All right, so there's a statue located at 100 meters east and 50 meters north of the origin. So if we start at the origin, 0, 0, go 100 meters to the east or to the positive side, we get positive 100 on our x-axis. Start at the origin, go 50 meters north, we end up at positive 50 on our y-axis. So the coordinate of our statue here is 100, 50. All right, and the question is, at what point on the highway, remember that this car is tracing this parabola-shaped highway, it's traveling along this highway. So at what point on this parabola-shaped highway will the car's headlights illuminate the statue? All right, how do we go about this? So the key realization for this problem is that the car's headlights come straight out of the car. And the thing to realize here is that the car's headlights follow the path of the tangent line to that point. So wherever the car is on the parabola, you can trace where the headlights go by the tangent line. Why does it have to be the tangent line? Well, think about it. If we imagined the headlights not going along the tangent line, it would go in a way that's not coming straight out of the car, like at a bent angle. We know that headlights come straight out of the car. So what does that mean? So if headlights come straight out of the car, then we know the headlights have to go in a straight line onto our point 100, 50. If the headlights go in a straight line and hit 100, 50, the headlights will hit and illuminate our statue. So basically, we have to find the tangent line that hits this point, that hits 100, 50. If we can find the equation for this tangent line, we can figure out which point on the parabola that it's at. So one place that I think would be good to start is to figure out the parabola. So if we remember, a tangent line, essentially, we have to take the derivative of our function. So we can't take the derivative without knowing our function. So let's figure out what our function is. I'll do it in this color. So because we're told that our function is a parabola, let's say y equals f of x. We'll call our function f of x. Because our function is a parabola, we know that it is a quadratic. The highest term is x squared. So a quadratic is usually, if we look at it in factored form, is usually in the form I should use a different letter there, a times x minus b times x minus c, where b and c, if you plug in b here, you'll get 0 for your y value, and if you plug in c, you'll get 0 for your y value. So we can see that this parabola has roots at 0, 0. There's no other point on this xy plane where the parabola crosses the x-axis. So that means that b is equal to 0 and c is equal to 0. Well, that simplifies our equation a lot. We can say that y is equal to a times x minus 0 times x minus 0, because we know that both roots for this function are 0. So we know that x minus 0 is really just x. So we can say that y is equal to a times x squared. Why is there this a out here? Well, for any function that has its vertex at 0 or both roots at x equals 0, we can stretch out the rest of the parabola while keeping the roots at 0. So that's why we have this a here. We can stretch out all the other points of our parabola or squish them in closer to the x-axis. So how do we find what our a is? Because that's a constant. We need to find that. Well, we can just plug in some point on this parabola that we already know. Do we see a point like that? Well, we can't use this point because it's not on our parabola, but we can use this point because we know the car travels along the parabola and it starts here. So let's do that. Let's plug in the point negative 100, 100. So we know that this is our x-coordinate, and the second one is our y-coordinate. So if we plug in 100 for our y-coordinate, we can can say the 100 is our y coordinate. We'll keep a because that's what we're solving for. And for x, we'll plug in negative 100 because that's our x value for that point. And we have to square it, of course. So now we just isolate for a. So some simplifying we can do first, though, is on the left side, we still have 100. And we've got a here. Well, negative 100 squared, that's really just 100 squared because it's negative 1. If you square it, just becomes 1. So we've got over here 100 squared. So if we isolate for a, I'll put a on our left side, we can say that a is equal to 100, and we're dividing both sides by 100 squared. 100 squared. Well, if we have 100 squared in the denominator and 100 in the numerator, we can just cancel out one of those 100s. So a becomes 1 over 100. So what's the equation that we've got for this black parabola here? Well, the equation for our black parabola, f of x or y, it really doesn't matter what we call it, f of x is equal to ax squared, and we know that a is 1 over 100, and we have x squared because both x-intercepts of this parabola are at x equals 0. All right, now that we've got our f of x, I'm going to erase all the math we've done here because we'll need some space. What we have to think about is how can we make an equation that includes x sub c. I made it sub c because we have a car, c is for car. So how do we find an equation that includes x sub c? Because remember, we're told to find the point on the highway, the point on this parabola where the tangent line to that point, right? Because the tangent line shows where the headlights are going, where the tangent line to that point hits 100, 50, our statue. So we have to find that point on the parabola. Well, we can just find the equation of our tangent line, right? Because if we find the equation of our tangent line, we'll essentially be taking the derivative at x sub c. Our equation for the tangent line will include x sub c. So let's try doing that. If we can get our equation to have only x sub c in it, our equation for the tangent line, then we can figure out what x sub c is. So let's start doing that. Let's try to figure out the equation of our tangent line at x sub c. So I'll do it in this purple color. So let's remind ourselves how to make the equation of a line. So the equation of a straight line. Well, if we remember our point slope form, we can have y out here minus, here, I'll do it in this green color, minus y1, and that would be equal to our slope, which I'll write as m, times x minus x1, where x1 and y1 are any coordinate pair on this line, not on the parabola, on this line, right? And if you ever have trouble remembering this point slope form of a line, I like to divide both sides by x minus x1. Because then what that gives you is the definition of slope, change in y over change in x, right? Because this is also an xy coordinate on our line. And then you just multiply both sides by x minus x1. So what do we need to find? We need to find our m here, which is the slope of this line. So you might remember that the slope of a tangent line is very important. Slope of the tangent line at, I'll do this in pink for x, at x sub c, is, you guessed it, the derivative of f of x, not at any x, but at x sub c. The derivative, if we take the derivative of our point, we always get the slope of the tangent line, the line that passes through only the point that we plug into it. It doesn't touch any other point on f of x, which is our parabola. So we need our slope, which we'll get through taking the derivative of f of x, which is this expression right here. And we need one point. So I think one point that we could use for x1 comma y1 has to be a point that's on our tangent line. Well, what's one point that's on our tangent line that we know? Well, it's our statue, right? Because our headlights have to go and hit our statue, and the tangent line represents that path. So we can use the point 100, 50. So 100 will be our x1, and 50 will be our y1. All right, so I think we should tackle this part now, right? F prime of x. So let's remind ourselves that f of x is equal to 1 over 100 times x squared. So how do we take the derivative of this? Well, if we remember our power rule, right, that's when we have x to the power of n. So if we have, let me write an aside here, power rule. If we have a function that is x to the power of n, and we take the derivative of that with respect to x, we'll simply put the n out front and multiply it by x to the power of n minus 1. So another thing about taking the derivative of this constant, it's not affected. We just have to take the derivative of x squared. We just have to remind ourselves to multiply this constant back in later. So what's the derivative of x squared? Well, you can bring the 2 out to the front. We'll have 2 as our n here. And then what's 2 minus 1? Well, that's just 1. So we'll have 1 over 100 times 2 times x. And of course, that's just 2 over 50, 2 over 100 times x, which is equal to 1 over 50 times x. All right, that is our m. If we just take the derivative at x sub c, let's do that. So we know that m is equal to the derivative f prime at x sub c, right? So we have our expression for f prime of c here, so we just plug in. So m is equal to x sub c over 50. All right, we are ready to make the equation of this line. So if I zoom out a bit, we know that the equation of our tangent line, TL, at x sub c is y minus, and our y coordinate here is 50, that for the point that we're using, and that's equal to x sub c over 50 times x minus our x1. So what's our x1? That's 100, this point that we're using right here, and it's on our tangent line, right? Minus 100. All right, so how do we go about solving for this x sub c? Well, I see one problem here. We have 3 unknowns in this equation, and we want only one unknown. We want one equation where the only unknown is x sub c. We're looking for x sub c. So how do we replace this x and this y? Well, we can just plug in a point. Do we have any other known points on this graph? Well, where we know both of the numbers as actual constants? No, we don't have any other points on, sorry, not on this graph, on this line, right? We need another point on this line. Well, we can't plug in a point that we actually know, but one point that we can plug in, and this is a key realization, is we can plug in the point at x sub c. How? Well, we know the x coordinate at this point is x sub c, of course, but what's the y coordinate at this point? Well, we know that y, we can see it right here, but we know that y is equal to x squared over 100, right? Same thing as f of x squared over 100. So we know that the y coordinate at x sub c is simply x sub c squared over 100. I just plugged in x sub c where x is in this equation for y. I think you can see why that's helpful now, because we've got another point. We can plug in x sub c for our purple x here, and x sub c squared over 100 for our purple y. So let's do that. X sub c squared over 100. We can't forget the minus 50. And that is equal to, I'll do it without the brackets for now. And that is equal to x sub c over 50 times x sub c for our purple x minus x sub c minus 100, right? Because we still need this point 100 comma 50. All right. Well, look at that. Now we've got an equation that only includes x sub c. So that makes it a lot easier for us to solve for x sub c. Remember, for one variable, you only need one equation. All right. So I think we can tell that this equation here is a quadratic. How do I know that? Well, I can see this x sub c squared here. Remember, x, just like in a quadratic expression when we have x, and we're trying to solve for x, here we're trying to solve for x sub c. So how do we solve a quadratic? Well, always to solve for a quadratic, you want to bring all the terms to one side and then factor it. So let's do that. Before factoring it, we'll have to distribute this x sub c over 50. So let's do that first. Let me copy and paste our left side. So our left side is the same. And if I distribute this x sub c over 50, I get x sub c squared over 50 for our first term, because we're multiplying the numerators here. This is just x sub c over 1. So I've got x sub c squared over 50. And what's x sub c over 50 times 100? Well, if I have, let's say that this is x sub 50 times 1 over 50 times 100. That's the same, right? Because if I multiply x sub c times 1 over 50, I get x sub c over 50. And I'm multiplying that by 100. Well, negative 100, but we put the negative out here. So we just multiply 100 divided by, multiply by 1 over 50. So that's basically 100 divided by 50, which is just 2, right? So I don't know about you, but I always like putting the constants in front of the variable. So I'm going to do that. I'm going to put the 2 out here. So I just distributed this x sub c over 50 to x sub c. There's our term right there. And negative 100. All right, next step. Bring all the terms to one side. I'm going to bring it to the left side, and then we will simplify. So we're going to keep our term here, which is x sub c squared over 100. I didn't do anything to that term yet. That doesn't quite look like a squared, so I'll fix it. I'm going to bring the square term next to it, because remember, we can't add and subtract terms that are squared with a term that's not squared. So we have to add and subtract terms that are both squared. So here we have x sub c squared over 50. We have a negative 2x sub c on this side, which will become, if we add 2x sub c to both sides, it'll become positive 2x sub c on this side, right? Because if I add 2x sub c here, it'll just cancel out and become 0. All right, and we need this negative 50. We can't forget about the negative 50, because that is our term that has no x attached to it. All right, this is looking kind of messy, right? So we should simplify. Once we simplify, we can factor it. And once we factor it, we'll know, what does x sub c have to equal for this equation to be 0. That's how we always have to solve a quadratic. Because if we're able to factor it, we can see what basically x sub c has to equal, right? That's what we're trying to find. So that's how you should go about solving a quadratic. So let's look at our x sub c squared terms first. So we have x sub c squared over 100 minus x sub c squared over 50. So we have to make these have the same denominator if we're going to add and subtract them. Well, x sub c squared over 50 is really the same thing as 2x sub c squared over 2 times 50. Why am I doing 2 times 50? Well, that's just equal to 100. So now they've got the same denominator. And our x sub c term here, there's no other x sub c term to the 1 power. And there's no other constant term, so we don't have to do anything with that yet. All right, so if we just look at the numerator, right? Because when we're adding and subtracting fractions, we look at the numerator after we've got our common denominator. So we've got 1 x sub c squared minus 2 x sub c squared. Well, I'm pretty sure you can figure it out. We've got negative 1 x sub c squared, right? 1 minus 2. And we still have to keep our common denominator. So that is over 100. We've still got 2 x sub c here. And we've got minus 50. And that's equal to 0. And what I'll do to make it easier on the eyes, I'll make our constants equal, not equal, I'll make our constants in blue. So let's write this equation again, but with the constants in blue. Why? Because we're going to have to factor this. So we have an x sub c squared term here. So if I want the x sub c squared term by itself, I can just put the negative 1 over 100 beside it. So negative 1 over 100, I'll leave a space for x sub c squared. And I have a positive 2 here, and I have a negative 50. And that is equal to 0. All right, and I've got my x sub c squared term, my x sub c term minus 50 equal to 0. One thing that would make solving this a lot easier is if our coefficient next to our x sub c squared here was equal to 1. So let's do that. So how are we going to make this 1? Well, we're just going to multiply by negative 100, right? Because if we multiply by negative 100, the negatives cancel out. We'll have 100 in the numerator, 100 in the denominator. It'll become 1. And of course, what's useful about solving a quadratic this way is because 0 times negative 100 is, of course, just 0, right? 0 times anything is 0. So I'll still write negative 100 out here, just so you can see we're doing the same thing to both sides. So negative 100, and then this times negative 100, every single term. Here we just have the x sub c squared. And what's negative 100 times 2? Well, negative 100 times 2 is just negative 200. So negative 200, of course, x sub c. And then what is negative 100 times negative 50? Well, the negatives cancel out. So you've got 50 times 100. So that's 5 with 3 zeros. So plus 5,000. And of course, that is equal to 0. Now, do we see any whole numbers that we can take to factor this? Remember, when you're factoring a quadratic and the coefficient in front of x squared is 1, you want to find two numbers that add up to negative 200 in our case, add up to negative 200, and multiply to 5,000. Well, I'll save us some time here because the truth is we'll have to use the quadratic formula. There's no easy integer here that we can find. So we can say for the quadratic formula, it's usually x is equal to, but since x sub c is our x here, we can say that x sub c is equal to negative b over 2a, and it might be helpful to write what a, b, and c are here. So a is the coefficient in front of x sub c squared, so a is equal to 1. B is the coefficient here in front of x sub c without the square, so b is equal to negative 200, and c is our constant. So c is positive 5,000. So our quadratic formula is negative b over 2a plus or minus the square root of b squared minus 4 times a times c, 4ac, all over 2a. Now, most of the time you might see this as one term, but I like to keep this square root of b squared minus 4ac over 2a separate, because then if I find the negative b over 2a and this part separately, I can just add it to b over negative b over 2a and then subtract it. I just think it's easier to deal with this thing separately. All right, well, we've got a pretty, well, the rest of it is just arithmetic, right? We know what a, b, and c are, and we can just plug them in and, quote, do the math. All right, so we have negative, and I'll do our a, b, and c in blue so it's easier to see. So b is negative 200, and then we have 2 times a. Well, our a is just 1, but I'll write it anyway so you can see, and I should probably move this down a bit. So we've got plus or minus the square root of negative 200 squared minus 4 times a is just 1, times c, and c is 5,000. And of course, that's all over 2 times a, and a is 1. All right, now the rest of this just arithmetic. All right, well, what's negative 1, which is this negative out here, times negative 200? Well, that's just positive 200. And we have a 2 in the denominator. So we have 200 divided by 2. That's just 100. 100 for our negative b over 2a. And to that, we are doing plus or minus. We have, let's work with this stuff under the square root first. So what is 200 squared? And notice negative 200 squared, same thing, because the negative will be squared. And if you take a negative times a negative, you just get a positive number. Well, 200 squared, you can think of it as 2 times 100 squared, or you can just, so 2 times 100 squared, right? Sorry, squared. So that's just 2 squared times 100 squared. 2 squared is 4. 100 squared is 10,000, right? 4 zeros. So 200 squared, negative or positive, is 40,000. 4 times 10,000. Right? 4 zeros. And what have we got here? Well, we've got 4 times 1. The 1 doesn't really matter because it doesn't affect our math. So 4 times 5,000. So what's 4 times 5? That's 20. So if you multiply that by 1,000, we get 20,000. So we've got a negative 20,000 here. And in our denominator, we've just got a 2. 2 times 1 is just 2. Let's simplify this a bit more. Plus minus, so 40,000 minus 20,000 is 20,000. So let's just write that out for now and then see how we can simplify it more. So we've got 100 plus or minus, so 20,000. Let's think about how we can factor it so we can take something out of the square root. Well, 20,000. Well, I think of it as the same thing. Oh, sorry about how messy these square roots are getting. But you can think about it as the same thing as 100 squared, right? Because 100 squared is 10,000. What times 10,000 is 20,000? 2, right? If you take this, you get 10,000. 10,000 times 2 is 20,000. So under the square root, you've got 100. And you've got 100 squared. And you're taking the square root of that. So really, you've got a 100 in this numerator. So this is equal to 100 plus or minus a 100 in this numerator. And you still have the square root of 2 here. And of course, this 2 in the denominator did not change. We still have this. So I hope you can see the simplifying here. 100 is just 50 times 2, right? So this 2 cancels out, becomes a 1, and this 100 becomes a 50. So really, our answer, with all the simplification that we can do, is 100 plus or minus 50 plus the square root of 2. So one very last important thing that we have to think about is, do both of these answers count as a valid answer? Because we have 100 plus 50 square root of 2 or minus 50 square root of 2, right? 50 times the square root of 2. But are both of these a valid answer? Well, we can refer to our diagram. And why are there two answers in the first place? Well, the reason why there are two answers is that there are two places on this parabola where you can make a tangent line, that passes through 100, 50. You can make one here, where the tangent line goes from the car forward into the statue, or you can have the car be here, and you can have your purple tangent line come out and hit the statue. Not a very accurate line, but just imagine that it is. That line can go and hit the statue from the back of the car. Do we see a problem with this second line? Well, the problem is that it's asking where on the highway will the car's headlights illuminate the statue? If the car is here, the headlights would have to shine the statue from the back. Are there any headlights on the back of this car? No, there aren't. We can see that from this diagram. There are no headlights coming out the back of this car. So really, the only valid answer is this point right here, not this point. So this point, check, this is the one we're looking for. This point, no good. There are no headlights coming out the back of the car. So which one is this? Is this 100 plus 50 times square root of 2 or 100 minus 50 times square root of 2? Well, which one is a lower value? Well, it's 100 minus 50 times square root of 2, right? So is x sub c equal to 100 plus 50 times the square root of 2, or is x sub c equal to 100 minus 50 times the square root of 2? Well, this is an x value, right? We have to think about where along our x-axis this point is. Is it at the higher, more positive point, or is it at the lower point? Well, it's at the lower point because the car is traveling towards the east. So its headlights are always pointing to the east. It's pointing in front of the car in the direction that it's going. So we know that it's the lower point. It can't be this point because this is a higher number on the x-axis. It has to be the lower number. What's the lower number out of these two? It's this one. This one? This one is the incorrect point. So we know that x sub c is equal to 100 minus 50 times the square root of 2. Now there's one last point. It's asking for the point on the highway, right? Point means an x, y coordinate. So we don't have the y coordinate yet, but we can find it. We have this equation here that can give us that. Or we could also use this equation right here, but it's a little more complicated. So I think it's easier to use our f of x. Why? Because this point is on the tangent line, x sub c, but it's also on a parabola. So we can use either equation. So we are finding f of x at x sub c. So that is equal to 1 over 100 times, and I'll do it in pink here just so you know it's x sub c that we're plugging in, 100 minus 50 times the square root of 2 squared, right? Because we have x squared here in our f of x. All right. I am sure you can plug this into a calculator or work it out yourself. This video is getting pretty long, but I hope this helped. Just so you know, the point is 100 minus 50 times the square root of 2. That is the x coordinate of this point we were trying to find right there. And the y coordinate is 1 over 100 times 100 minus 50 times the square root of 2 squared. Alright, that was long, but I hope that helped.